All right, on tonight's episode of Python Papi, we're back inside our generative AI course. Let's have a look at what we went over tonight. Now, last night, if you recall, the last topic we touched on was the LSTM, and tonight we're going to pick up where we left off. So, if we look at the architecture of the LSTM, we will see that along with the timestamp, we would have this settled state. This is our settled state here, and this is our timestamps. In the settled state, this will maintain our long-term dependency. As you recall, the RNN is mainly used for short-term memory, so we would use something like the settled state here to handle our long-term dependency. We will have connections between the settled state and the timestamps that are called gates. These three gates will be the forget gate, the input gate, and the output gate. This will look something like this. So we have our settled state, we have our timestamp, and then they're connected by these gates here. We have our forget gate right here, we have our input gate here, and then we have our output gate here. These are the three gates inside our LSTM for sustaining long-term dependency or maintaining long sentences. Now we will look at one more updated version of the LSTM, which is known as the GRU. And the GRU was created in 2014 and it was taken specially from the LSTM. Inside the GRU, we won't find the concept of the settled state. We'll just have two gates, the save gate and the update gate. This is considered an updated version of the LSTM. These three architectures or models, the RNN, LSTM, and the GRU, were very popular from 2018 through 2020. And by using these particular architectures, we are going to process sequence data. One concept to keep in mind is sequence to sequence mapping, and for that only, we are using these particular architectures. We have different types of mapping techniques for other scenarios. We will list them below. We have the one-to-one, we have the one-to-many, we have the many-to-one, and we have the many-to-many. We can actually implement these mapping sequences by using the RNN, LSTM, and the GRU. If we're talking about these particular sequences, we can definitely create various applications by using our three models, but these sequences come with restrictions. Some of the applications for these sequences include one-to-many, which can be used for image catering, many-to-one can be used for sentiment analysis, and many-to-many can be used for language translation. Now, we didn't get one for one-to-one. I don't know why he left that one blank, but whatever, I left it blank also. I guess I have to do my own research on that and see what the one-to-one can actually handle for us. Now, if we're talking about the sequence-to-sequence mapping, we can definitely implement it by using these particular architectures, the RNN, LSTM, and the GRU. The problem we would have, for example, if we had an input of 5 words, we would need an output of 5 words as well. So it's a fixed length for input and output. Using sequences like many to many will cause issues because of the fixed length. Whatever number of inputs we enter in terms of the many to many we are talking about, we need to have the same number outputted. Because of issues like this, a solution was created in the form of a sequence to sequence learning, which gave us the concept of encoder decoder, which if you've been listening or paying attention for the last few videos, that's actually one of the last concepts we went over in our artificial intelligence course was the encoder decoder. So yeah, it seems like we're picking up right where we left off in our artificial intelligence course was a good thing because everything's running concurrently and I didn't even know it was going to go like that, but hey, it's all good for us. And I'm going to leave it there for now. Like I said, I don't want to start moving too fast ahead. I want to make sure I have everything down packed, even though some of the concepts are still fresh in my mind. We are coming across new concepts as well. So I want to make sure I have a hold on everything before we just start moving forward. So we're going to pick it up tomorrow. But of course, I will keep you posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.